So let's go ahead and then look at some strategies that you must be aware of when doing an integration involving a product of tan x and sec x, which involve powers. Now, to integrate tan x, to integrate like the integral of maybe tan to the power of let's say n of x, sec to the power of k of x dx, you must follow these steps. The first step that you need to follow, is if k is even, that is if k, the power of the sec, is even, and the same k has a value which is greater than or equal to 2. That is if k is even. That means if k is 2, 4, 6, 8. And from here, that's what it means. You can rewrite the question which has been given to you as sec to the power k of x, which is equal to sec to the power k minus 2 of x sec square of x. So when you do this, there's something that you can do here, and we are not doing this just for doing sake. Remember that for the sine and then cosine functions, we were having cos square of x plus sine square of x equal to 1. And then you make, that means that you reduce 1 in such a way that we are going to get maybe sine of maybe k minus 1 multiplied by sine of x. But in this way, there's a particular identity that we want to use, and for that matter, we need to express it in such a way that we will get sec x attached to it. That is if the power of the sec is even and is greater or equal to 2. Then you can reduce it like this. When you are done reducing it, this is another trig identity that you must also keep in mind. The trig identity is sec square x equal to 1 plus tan square of x. So with this identity, you will be able to substitute this inside and rewrite everything in terms of tan x. And at the end of the day, since we reduce the sec x, which is similar to the sine and cosine functions we did, we are going to take our tan u to be equal to our tan theta value or our tan x value. So just remember that. And at the end of the day, you are going to get something like your du dx of this tan is going to be given to us like sec square of x, which has been stated above, and then this will help us to eliminate this extension that we have done here. This is very crucial, and then you must keep it in mind. The second strategy is that if this value of n, this n value is odd, if n is odd, okay, let me before I proceed, let me write this one over here before I proceed. That's integral of tan to the power n of x, and then sec k of x dx. So looking at this, the second strategy tells us that if the value of n is odd, that is if n is odd, and k is greater or equal to 1, we must rewrite it as tan of k of x sec of x, which is equal to tan to the power k minus 1, or let me do it this way, not to confuse anyone. So if n is odd and k is greater than or equal to 1, then what you need to do is that you need to write tan to the power n of x multiplied by sec of k x, sec to the power k of x, and then it should be equal to tan to the power n minus 1 of x, and then we are also going to multiply by sec to the power k minus 1, and that of x. When you are done, you multiply it by sec x and then tan x. That means that if you multiply these sec x tan x to these ones, we are going to get the same thing back. Tan to the power n of x multiplied by sec to the power k of x. That's what you are going to get. So nothing changes from there. So when you are done with it, we use the same identity, 1 plus tan square of x, which is equal to sec square of x. And for that matter, you have to make tan square of x the subject. So tan square of x should be equal to sec square of x minus 1. And in doing so, you can rewrite it as, when you are done, you can rewrite the tan value as tan to the power n minus 1 of x in terms of sec x. So when you are done, since we manipulated the tan, we are going to take our u to be equal to our sec of x. And for that matter, we can say our du dx is equal to sec x tan of x dx. When you are done, note that your k is even and then your k is even and then your n is odd. Therefore, either strategy or strategy 2 may be used. So if your k is the first one, let's see, if your k is even and your n is odd, then either strategy 1 or strategy 2 may be used. Any of them that you want to use will help you a lot. So let's look at the third strategy. This is strategy 3. Let me also rewrite here for easy reference. So the integral of tan to the power n of x, and then we multiply by sec to the power k of x, which is sec to the power k of x. And don't forget that it's all dx. So when this is the question, or this is our reference point that we are looking at. So considering the strategy 3, if your n is odd, where your n is greater or equal to 3, that is, if your n is odd and the n is greater or equal to 3, which means the n can be 3, n can be 6, n can be 3, n can be 5, n can be 7, n can be 9, and so on and so forth, right? So if your n is odd and where n is greater or equal to 3, and let's say your k is equal to 0, that means the power of the sec is 0, you can rewrite everything as tan of n of x to be equal to tan of n minus 2 of x, similar to the first condition, multiplied by tan square of x, which is equivalent to tan to the power k minus 2 of x multiplied by sec to the power x power 2 of x minus 1, which is in the brackets. In this case, we made tan square x from the identity that we discussed above the subject, and then we substituted it. And at the end of the day, we are going to get an expression as tan to the power k minus 2 of x, and then sec square of x minus tan to the power, I'm using the little interchange to tan to the power n minus 2, and then tan to the power n minus 2 of x. So sometimes it will be necessary to repeat the process for the tan to the power of n minus 2 term. So it's very important to take note of all these things. Let's look at the last strategy. This is strategy 4. As usual, the tan to the power n of x, and then sec to the power k of x. So for this one, the 4 tells us that if our n is even, and our k is odd, then we can use the identity as by making tan square of x the subject, and then we get the resultant term to be like sec square of x minus 1, and therefore it will help you to express tan n of x, or tan to the power n of x, in terms of sec x, right? It will help you to express tan to the power n of x in terms of what? Sec x. So for this matter, we will use integration by parts to integrate all powers of sec x. So we should take note of that. Now that we understand the strategy, my next video will be on evaluating some examples which make use of these techniques that we have learned